You basically go from unstructured information to something that has more structure to it. Still somewhat unstructured, but it has more structure to it, and before. Plus, you've also reduced the clutter. You kind of highlighted what's interesting out of this. And this is the kind of stuff you get out of it. So, for example, I snapped this late last night, but you get an idea immediately of what's possible with this. So here, I've actually cut across a number of different news sources, and this is kind of scaled down. But you can see how everything kind of related to the Charles and Camilla wedding yesterday is grouped together as a single set of stories. So if I don't care about this, I've instantly reduced my workload, but I also found kind of within a page all the interesting things. So if I was curious about this, I've got it all in one centralized place. And because everyone's talking about it, it must be interesting, right? It's kind of the base assumption of this. You can, of course, ignore it if you really want to. But typically you'll find very, very interesting things here. And this is also the output of it as well. It's kind of ugly HTML, sort of functional. I basically whipped it up at like 2 in the morning one night. But it more or less works, and I haven't really had to change it. But you can see that I've got the AP here, I've got NPR, Reuters, New York Times, et cetera. All these kinds of things basically feeding this news site, grouping together and cutting across them. And so if I wanted, for example, to get the New York Times perspective, that's easy to do. You don't see here, for example, is the Guardian or the BBC. For example, if I wanted the British perspective, India Times, if I wanted the Commonwealth perspective, for example. All these kinds of things are possible because now you can kind of cut across dozens of different news services, find the interesting things based upon what they're talking about, group them together, and now you have a centralized place to get information about a topic. Very, very useful, and very, very interesting indeed. This is a cluster Cosmos that I developed a couple of years ago, about a year ago actually. And what's interesting here, these are basically stories grouped together and then graphed. And this is forms kind of a cosmos here, and sort of like Cameron over here is an astrophysicist, and I'm sure he probably winces at the use of that term, but it's kind of an ugly star chart, right? But what's immediately obvious here are a number of things, and that's kind of the idea that these lumps or these clusters are very, very intuitive, right? So here we have, for example, a very popular subject that's actually receiving a lot of attention from the press, and a few others that are kind of that big, a lot of smaller ones and some medium-sized ones and stuff like that. Again, really, really interesting and very, very intuitive, and that you can quickly scan this. You can look at it and say, okay, what's interesting here? I don't actually work with this kind of visualization. I simply use it to kind of measure the quality of the grouping here. But you can kind of see how things kind of lump together like this instantly. So you're probably wondering how you get to do this yourself, right? It's kind of a relatively simple process that has a few direct steps to it, and it doesn't really have to iterate very, very deeply. So in step one, basically what you do is you gather all of the feeds together. And again, this is some data from last night on the actual aggregator system that I use. You actually gather all the information together, and so now you have this kind of corpus of news items. And I gather something like about 1,000 together at a time. Because I'm reading something like 60 sites or something like that, I think, at any one time. But basically what you get is a list of news stories, and we can actually do this just on headlines alone. Don't even have to look at the bodies of the news stories to do this. So in step one, you've gathered them all. You can see kind of, I've actually chosen, if you will, in this case, a very specific cluster of stories, but you can see how these naturally fit together. And in step two, what we do is we drop what are called stop words. So in search engine terminology, stop words are things that don't add any real semantic meaning. So they're, in this case, it's a lot of the word to. It's kind of dropped out. If you can see it clearly, it's kind of in light blue. But basically, things that are simply too small or things that are simply too common and aren't unique to a story, specific to a story, you basically drop them out because they have nothing to really add here. And in step three, then you stem the words. So what I use here is what's called the Porter-Semmer algorithm. Very, very simple algorithm, very direct, kind of almost naive in a lot of respects as well. And what it does is it takes the words basically and drops common English endings. So it drops the ED, it drops the ERS, it singularizes them, drops the ER, it drops at least all the modifiers, these words, and you're left them with a root word. In this case, all these stories are centered around the word bomb. Yes?
Do you use a dictionary to make sure that you're not turning things into TH, for example?
I think actually in the algorithm itself, I think it has kind of checks like that. It doesn't quite use a dictionary. I think it uses a few thresholds, like does it contain, not just consonants but also vowels and stuff like that. It is a really dead simple kind of almost like I said, naive kind of implementation of stemming words, but it's basically kind of one of the common things in natural language processing. I would actually drop out th out of that because you've gone from things to thing, then to th as you note, because it's simply too small and simply isn't interesting anymore. But that is, I think, a concern. I haven't run across it, so looking at it, I think it basically looks for, essentially is a kind of a word, but it doesn't use a dictionary. But again, what's interesting is you've kind of reduced kind of the clutter down into kind of a common term here, in this case, bomb, right? So Eric Rudolph is associated with the word bomb, and all these stories are associated with the words bomb, right? He was a bomber, he had a bombing, something was bombed, etc. All these relate to bomb. And in step 4, we then perform basically a two-step process. We find the most frequent words, the most frequent stems, and we then rank order them from most to least frequent, group them together, and then we basically find all these stories related to this. So we basically walk down the list. So bombs, or bomb rather than Camilla and Charles, et cetera, and so on and so forth. And you kind of walk down the list of stories here, and you basically pull them out of this database, throw them then into a cluster. And what I typically do to achieve a layout like this is I actually choose the one that's the longest, because it's going to have the most information in the description. Not necessarily the best or the most interesting, but it just has the most information kind of at the top of this, because I only display this description for the first one, and all the other ones, it would just be too much clutter. Wouldn't really help the process along at all. There we go. But basically, you find the most frequent stems, because you basically sum them up, and then you down to the least frequent ones, and you basically pull the stories out. Now, stories can only appear in one group. So the goal here, and the implicit assumption, is that it's going to basically be a very unique identifier. It's not going to be a very popular identifier. So Charles and Camilla, for example, is probably not going to appear in any one day frequently in any other group of stories, for example, but it could. So, for example, the term Iraq, for the past 2 years, has appeared kind of in multiple subtopics, if you will, but it's typically all grouped under Iraq. So, for example, you have elections, you have bombings, you have Iraqis getting pissed off about stuff, and so on and so forth, and all these things are kind of all subtopics, but they're all, unfortunately, grouped under the term Iraq. And so that has kind of a natural consequence here with that as well. Yes?
How do you deal, if you're just assigning one cluster, how do you deal with collisions?
Collisions meaning like a story should appear.
In Iraq, you have some bombing list, right?
Well,
just whatever pops up first.
Whatever pops up first. It's another unfortunate assumption, if you will, in the model, and that is that more or less that these are unique identifiers kind of across all stories, which is not necessarily true as well. I actually have some sort of manual. It's not basically, it's kind of built into my method and my implementation of the method, but it's not really inherent in really any of the algorithms that I'm stealing from other people and using for other people to kind of drop things that might cut across basically a lot of different topics. So, for example, I actually rip out the word security because it applies to Iraq and Social Security, which itself are not very, very interested. But if two of them were talking about it, right, securities would appear basically at this as a frequency that is the sum of both the Iraq security and the Social Security problem as well. It would dominate over Social Security and Iraq as well. And so I drop things like that out of it as well. But basically because they're not terribly interesting identifiers kind of in the end, and they do have a lot of false positives. And so that kind of collision and that kind of thing I do take care of. I have thought about taking care of the first case I described, the Iraq situation, for example, where you have 2 or 3 different subtopics underneath that, by actually looking at the size of the resulting cluster, and if it's over some sort of threshold, right, basically performing a second analysis on just that. Find me the next most interesting terms out of this, which might be, for example, soldiers getting killed, which might be then voting, which might be parliament and stuff like that. So then 3 natural subgroups that kind of pop out of that. And then you basically discard the word Iraq because it's no longer a unique enough identifier in that case for that group. But these are subgroups and that kind of become parent groups, if you will, in that respect. So I haven't yet implemented that, but that's basically the way I think that probably the simplest and very useful way to do it, I think.
It seems like it would also kill off the need to do the blacklisting of the word security, because it would naturally take care of it.
In theory, yeah, in theory, but I think that it's probably an issue kind of that threshold, right? So really within any group, you're going to find subgroups, right? Over 2 or 3 different headlines grouped together, you're going to basically have maybe 1 or 2 different subgroups within that. And so I have to find that magic threshold and see if it's distinct enough. Melinda?
Something that's endemic to things that use clustering is the problem of choosing how many numbers of clusters to use. So it's just that it's pretty much, I mean, if you have genetic research, if you have software engineering stuff that uses clustering, that's basically one of the big unanswered questions is how many bins do you divide this thing into? And there's really no way around it.
Yes and no, right? So that's most popularly implemented as the k-means clustering algorithm, right?
Yeah.
Where you basically say, I'm going to have n clusters or k clusters in this case, and then you basically try and you seed them, and then you basically iterate until they're stable. Yeah. I'm actually not doing that. So this is actually a great segue into kind of differences between what I'm doing here and other techniques that you might expect as well. I use the term clustering kind of loosely. I'm not actually doing great clustering in the sense of hierarchical clustering, k-means clustering, or star clustering, being 3 very popular techniques to do that. But I'm actually more doing kind of a grouping or kind of a lumping even, right? So let's not even call it clustering, let's call it lumping, if you will, kind of lumping them together. But the other thing I think that should be apparent by this point is that unlike a system like Bayesian classification techniques or other kinds of even k-means in this case, right? We'd actually have to kind of assume what the centers are going to be. Right? So a lot of folks like to think about classification in terms of Bayesian analysis because it's what they're most familiar with after Paul Graham's Plan for Spam essay. It turns out that Bayesian techniques wouldn't necessarily work very well on this because you have to basically know what the clusters or the groups are going to be in the first place. So it turns out that doesn't work out very well. So I'd have to basically sit down like once a week, think about what's happening now, what's likely to happen in the future. This whole thing basically is self-driven. Based on word frequencies and stem frequencies, right? That's how it works. And so basically finds interesting things that pop out of nowhere, if you will, that he wouldn't have been able to come up with in the first place. And secondly, most people typically use Bayesian classification mechanisms either in spam or even in RSS clustering as kind of a few kind of larger groups of things. Like this is news, this is technology, this is fun, this is whatever. And here, this is all news, right? This is only across news sources. And so it's all news, duh. But I can't really, I guess I could call it domestic and foreign, but that doesn't really kind of give me the fine-grained analysis I'm looking for as well. And so unlike Bayesian techniques, I don't really have to know, if you will, ahead of time what these clusters might look like. And same thing with k-means clustering as well. I could probably randomly pick centers, but again, that I don't think would necessarily work as well as it might actually work better. I don't know. I haven't implemented it, but it seemed harder to do, and this seemed to kind of do the job for the most part. And I wasn't quite sure the benefit of that over kind of a brute force word frequency, stem frequency approach. I could, I guess, pick 100 different clusters or whatever, but then I'm kind of limiting myself, if you will, as well to that number of clusters, and finding the interesting ones in that may or may not necessarily work as well. Also, k-means clustering is somewhat slow with respect to things. You have to actually iterate repeatedly to kind of wait until the clusters themselves stabilize, because you basically, the k-means clustering algorithm is really, really simple. As Melinda pointed out, you basically pick some centers, and you throw darts, basically, and you find things that are kind of within some sort of distance within that. And also they come up with a distance algorithm as well, which may not necessarily work out so well. I could look at Levenshtein or Hamming or something like that, but it doesn't necessarily work all the time. You have to have some sort of higher-order semantic meaning, I think, rather than just the actual characters themselves. So once you actually pick the centers, you basically find the things within a certain distance, you call that a cluster, and then you recalculate the center of that cluster based upon the data within the cluster. You repeat this process ad nauseum until basically your clusters stabilize such that they aren't changing from one iteration to the next, or they reach some sort of threshold level that you're happy with. There's some sort of tolerance that you're happy with. It's terribly slow, unfortunately. But also, I don't have a good distance algorithm, which is probably the other reason why I didn't do it. Rick?
So this to me seems like a classic example of the hacker mentality that we have a lot here, in that there's all these fancy algorithms, these are very simple, and It might not work quite as well as those in many situations, but it seems to work pretty well.